Katherine Carter doing math vocabulary. Okay. Triangles. It's a polygon with 3 sides and 3 angles. So this is, title label is A, B, C. That would be triangle, A, B, C. This is an isosceles triangle. It's a triangle with 2 equal sides. These 2 are equal, and then this one's different. But it does have the same triangle, does have the same labeling as a regular triangle. An equilateral triangle is when all sides and angles are the same. So what a triangle needs to do is it needs to, all of these will add up to a specific number. I think it's 180. Yeah, it is. A triangle with no equal sides is a scaling triangle. So this ones are all different. A right triangle is a triangle with 1 right angle. And you can do that by doing a box to show that it is a right angle. And as you have probably noticed throughout this, it is not exact, especially with the parallel lines stuff. This is definitely not an exact thing. Just going to tell you now because that square is really bad. An obtuse triangle is a triangle with an angle over 180 degrees, but then these two will be under 90 degrees, over 90 degrees. An acute triangle is a triangle with angles, all angles under 90 degrees. So this is under, this is under, and this is under. A quadrilateral is a polygon with 4 sides. 1, 2, 3, 4. And you label that by A, B, C, D. So that is the quadrilateral. And quadrilaterals are not just rectangles and squares. They are rhombuses, trapezoids, anything with, but yeah. As you'll notice, polygons later in this presentation, so you'll understand. A square is a quadrilateral with all equal sides and all angles 90 degrees. So all of these are boxes, and all you have to do is that, because that means that these two will obviously be that. But all of these are equal sides. Rectangle. A quadrilateral with 2 pairs of equal sides. So these are the same size, and these are the same size, but obviously these are not the same size. Wait, you can't see that. But these are not the same size. Point. Right, yes, point. Point. Which is a dot that specifies a location with no dimensions. So, oops, this would be point B. And this is a more regular example, but this would be point C. This is a straight side. Oops. This is a line, a straight path that goes on for infinity on both ends. So as you'll see, let's just so like this is point A, point B, but this still has 2 arrows which means it goes on indefinitely. Plane. This is a flat surface, so this is a plane, this is a plane, this is a plane. Under here would be a plane, but all sides it is plane because it has no ridges or anything. It's just flat surface. Ray. One side with a point, which would be this. So that this is point B. That like doesn't go on, but then there's one side going on indefinitely, shown by this arrow. But obviously there needs to be another point just to get, so this is ray BC, shown by ray BC. And the line would be that's just never mind. Angle, which is two rays with the same ending point. So these both are two rays. I wanted to make it bigger than those two thin lines, but this all has the same ending point. Should have used the laser pointer. Oops. But anyway, these have the same ending. So this is like point, like this is point B, and this is ray BC, but this is line. This is ray BA. They both end at the same ending point. Line segment. A line with 2 points. So, like if this was a line going like that and like that, and I think my thing has stopped. One second. Oh, never mind. It hasn't. Sorry. But anyway, we only have 7 minutes left. So, 3 minutes left before I have to stop. And then, but anyway, so this is a line with 2 points. So let's say this is a line. Oops. Let's say that this is a never-ending line. Well, this, if it has 2 points, and this is BC, this would be a line segment. Polygon, made of straight lines in a closed figure. So it is completely enclosed, and it's only made out of straight lines, no curves. If it has a curve, it is not a polygon. A right angle, an angle that is 90 degrees, shown by the square. Obtuse angle, an angle over 90 degrees. Acute angle, an angle less than 90 degrees. Parallelogram, a polygon with 4 sides that has 2 pairs of parallel lines. So these are parallel. These are parallel. These are parallel. They will never intersect. Rhombus, a slanted square. So pretty much a regular square, but it's just like you pushed it over a little bit. But everything is still like a square. They all have the same angles, and they all have the same size. They have the same length sides. A trapezoid, a polygon with one set of parallel lines. So these will never intersect, but these will. Pentagon, a 5-sided polygon. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 5 sides, 5 angles. Hexagon, a 6-sided polygon. 1, 2, 3, 4, 5, 6. And as you notice, I do not have all of them on here because you didn't give us all of them today. Octagon, an 8-sided polygon. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And for a brief interruption, sorry if I paused. But anyway, octagon, an 8-sided polygon, and decagon, a 10-sided polygon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Parallel lines. Lines that will never intersect. As you see, these are not exactly straight. These would intersect, but I do not have a completely straight line available when I was making the slideshow. So these lines will never intersect. Perpendicular lines. Two lines that intersect and form a right angle, which can be represented like this. Obviously not perfect. Intersecting lines. Lines that cross. These are just crossing lines. Supplementary angles. Angles that add up to 180 degrees. See, this is a straight line. And remember, they are made out of rays. But it creates, the straight line is 180 degrees. But let's say, no, this is not accurate. But this is this is 50 degrees. So this side would be 130 degrees, making a supplementary angle. Complementary angles, angles that add up to 90 degrees. So this is 90 degrees, but this is 30 degrees, and so this would be 60 degrees. Yeah, 60 degrees. Vertical angles. Angles that, when lines cross, angles are always equal. So, all these angles are equal, and all when put together, they are 360 degrees. Thank you for watching my presentation. I hope you liked it. Thank you.